Alrighty, hi again. We're going to start the next section on this video, which is section 11.2 in the book that we're using, which is, for those of you who are coming from someplace else, Stewart's Calculus 11.2. And we're going to talk about infinite series, which we can think of as infinite sums. So the idea is we're using summation notation. Hopefully you've seen summation notation before. One of these days I'll get a video up on it if you haven't. But what this notation means is we're going to start with we're going to scroll through all of the integers from I equal 1 on up. So I here, this variable here is called the index of summation. And this expression here is the terms in the summation, but this expression is a function of I. So if I equals 1, I get A1, which is some number. And I equals 2, I get A2. And if I equals 3, I get A3. And this sigma, that's what that symbol is, capital sigma, the Greek letter sigma, means you're summing all of those. Now, at this stage, you should be asking, what is it mean to take an infinite sum? Because an infinite sum is not really that well defined. We know what a finite sum means, but what does an infinite sum? So right now, I want to try and put some meaning on what we mean by an infinite sum or series. Series is another name for an infinite sum. When we can talk about what that sums to or converges to, and when we don't have a meaning for that. So in order to talk about it, we're going to talk about the sequence of partial sums. Now recall the last set of videos we made, we're talking about sequences. So we know about sequences, we know, what it means for a sequence to converge, and we're going to describe the series converging in terms of sequences converging. So the partial sums are just finite segments of the series. So the nth partial sum is going to be just the sum I equal 1 to n of ai, which is just that finite sum, a1 plus a2 plus dot 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 plus an, which we'll call sn, which is just to let you know it's just some term in the sequence. So s1 in this would be the sum, sorry, that's s1, the sum I equal 1 to 1 of a1, s2 will be the sum I equal 1 to 2, S3 would be the sum I equal 1 to 3, and of course that sum, the first S1 is just this, has one term in the sum, A1, S2 has two terms, it's A1 plus A2, right, goes from 1 to 2, there's only two integers there, 1 and 2. The third one would be A1 plus A2 plus A3, and the fourth one would just be adding on the next one, A1 plus A2 plus A3 plus A4, and that's the fourth partial sum, which we're calling S4, right? So they form a sequence. Those partial sums form a sequence, and we know very much how to add a finite number of terms. So we're going to say that this series converges to the limit of that sequence of partial sums. The limit as n goes to infinity of the sequence of partial sums if that limit exists and is finite. And that's a definition, so let me put a colon here. It's defined to be that limit if that limit exists and is finite. Otherwise, we say it diverges. So if that limit exists and is finite, that means it converges. It converges. Okay. Sometimes that limit will be infinite, in which it will say it diverges to infinity, or negative infinity, in which case we'll say it diverges to negative infinity. Sometimes that limit, the terms of the partial sums just bounce back and forth and don't zero in on anything or go off to infinity or negative infinity, in which case we just said it diverges, period. Okay, so let's look at this example. Okay, so we're going to look at the sum. So we're going to try to understand the sum I equal 1 to infinity of 1 over 2 to the I. Okay, so let's look at the partial sums here. I'm going to look at it graphically first. okay, on the number line. So if I look at the number line, let's start at 0 and go to 1. So the first partial sum, when n equals 1, we're going to get just 1 over 2, right? So that's going to be 1/2. The first partial sum, S1, is just 1/2. So we take a 1/2. So this is going to be S1, my first partial sum. Now when n equals 2, I get 1/2 plus 1/4, right? So when I add 1/4 to 1/2, where do I get to? Well, 1/4 is half of 1/2, right? So I get halfway between 1/2 and 1, which is 3/4. So I take 1/4 and add it to 1/2, and I get 3/4. So that's going to be my second partial sum. So we're going to try and get an expression for the nth partial sum eventually. But let's look graphically and see if we can guess what's happening first. So if I add 1/8, which would be the next term here, where am I going to get? Well, 1/8 is half of 1/4, so I'm halfway between 3/4 and 1. So if I add 1/8 to that, I get 7/8, which is what my S3 is equal to, 7/8. And then if I add 1/16, I get halfway between that and 1, 15/16, and add again, halfway between that point and 1. Where do you think it's going? Yeah, it looks like that limit's getting closer and closer to 1. As I keep adding one more term on, I get closer and closer to 1. So it looks, this series, of course, is going to be the limit as n goes to infinity of the partial sums if that limit is finite. And it looks like maybe, graphically, it looks like that limit might be 1. So let's see if we can show, in fact, that limit is 1. I want to remind you of the factorization of a polynomial. In case you haven't, well, let's multiply out some polynomials so I can remind you of factorization. I'm going to look at 1 minus r times 1 plus r squared plus dot 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 plus r to the n minus 1, right? If I multiply that out, I'm going to multiply the 1's through first. I get 1 plus r squared plus dot 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 plus r to the n minus 1. And if I multiply through by negative r, I get minus r squared minus dot 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 minus. So when I multiply negative 1 times r to the n minus 2, I get minus r to the n minus 1 minus r to the n. And notice this is equal to 1 minus r to the n. So in other words, 1 minus r to the n, let's write this in a different color. So in other words, 1 minus r to the n over 1 minus r is equal to 1 plus r plus dot 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 plus r to the n minus 1. So how can I write this? I'm going to write this as 1/2 times 1 plus 1/2 plus 1/2 squared plus dot 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 plus 1/2 to the n minus 1. I factored out 1/1/2, which is equal to 1/2 times, we just came up with a formula for that, times 1 minus 1/2 to the n over 1 minus 1/2. So as n goes to infinity, what's the only thing changing with this as n goes to infinity? It's this part right here. What's 1/2 to the n going to as n goes to infinity? It goes to 0. So this whole thing is going to 1/2 times 1 over 1 minus, so that goes to, it's not equal, it goes to that. 1 over 1 minus 1/2, which is 1. That's equal to 1. So this is true. That is 1. Okay, this is an example of a geometric series. We're going to talk about geometric series in the next video. Okay.